Proxima-B. Life may be evolving despite deadly radiation. Aliens' worlds are all around us. Scientists at the International Space Station have been studying Proxima-B, a distant planet in a nearby star system, for years. Recently, they reported new research that raises the possibility that the planet is still alive. The crew discovered proof of a subterranean ocean with flowing water. They also found that the planet's atmosphere is steadily thickening, which raises the possibility that the planet is engaging in some photosynthesis. Scientists warn that we still do not know much about Proxima-B despite these encouraging hints. Do you want to learn more about the Proxima-B? Watch this video through to the conclusion. For nearly 30 years, astronomers have been discovering planets outside our solar system, the universe's exoplanets. Almost every star has a planetary system. Most of them contain rocky planets with the potential to have liquid water on their surfaces. Finding the first proof of life outside of Earth is still one of science's holy grails, because where there is water, there may be life. Proxima-B, the first exoplanet ever discovered, was found less than 2 years ago by a research team from the European Southern Observatory around Proxima Centauri, the star in the universe closest to our Sun. The existence of enormous solar flares impacting Proxima-B often is just one of the many phenomena that would make life for humans in that world all but impossible. However, even so, there might still be a chance for life. The likelihood of existing on the planet Proxima-B will be examined in this video. Before we proceed, please give this video a thumbs up and subscribe to this channel for more content. In order to subscribe to view video alerts, click the bell symbol. Have you already put it into action? Let's continue. We were unaware of planets outside our solar system until a few decades ago. We now know there are countless planets in the universe, at least one of which is in the solar system next door. Thanks to developments in astronomy like the Hubble and the Kepler telescope. That planet, called Proxima-B, is being examined more closely by Cornell University scientists to see if it might be home to life. They cite Earth as evidence for their conviction that it very well might. Only 4.24 light-years separate the Earth from Proxima-B, which orbits the red dwarf star Proxima Centauri. In 2016, researchers declared the finding of Proxima-B. It has a mass at least 1.3 times that of Earth and orbits its parent star every 11.2 Earth days, indicating that it likely has a rocky surface. Proxima Centauri is a red dwarf, meaning it is smaller and colder than the Sun. As a result, even though Proxima-B orbits the star relatively closely, liquid water may exist on Proxima-B. Proxima-B is a suitable candidate because liquid water is thought necessary for the emergence of life. Even though there might be water there, the radiation from being so near to a red dwarf would render it uninhabitable for humanity. However, the radiation might not completely preclude the emergence of alien life on Proxima-B. 4 well-known exoplanets, Proxima-B, TRAPPIST-1e, ROS-128b, and LHS-1140b, had their surface UV radiation predicted by Cornell researchers Lisa Katlenegger and Jack O'Malley-James. It turns out that, in comparison to Earth's past, Proxima-B is not all that horrible. To determine how the powerful solar flares from red dwarfs affect the surface conditions, the researchers modeled several atmospheres for these exoplanets. Increased solar flare activity degraded the atmosphere as projected. That is bad news for life's progress, but as Dr. Ian Malcolm once said, life finds a way. With the Sun far younger than our own, the Earth was a harsh place 4 billion years ago. The surface radiation of every planetary model was lower than Earth would have experienced at that time. Why couldn't life exist on Proxima-B if it did on Earth? On Earth, organisms use a variety of biological defenses against radiation, such as radiation-resistant pigments and improved DNA repair molecules. Life is currently thriving on Proxima-B in a hostile environment. What is Proxima-B? Exoplanet Proxima-B is a super-Earth that revolves around an M-type star. It has a mass of 1.27 Earths, orbits its star in 11.2 days, and is 0.0485 AU from it. In 2016, news of its finding was released. Proxima-B experiences bursts of severe ultraviolet radiation that are hundreds of times stronger than what Earth receives from the Sun in the habitable region of its star, Proxima Centauri. That radiation produces enough energy to gradually peel away heavier elements like oxygen and nitrogen in addition to the lightest molecules, hydrogen. Proxima-B is not necessarily livable despite being in the habitable zone, the distance from its host star at which liquid water could accumulate on a planet's surface. For instance, it does not consider whether the planet has water or whether an atmosphere could endure in that orbit. A suitable atmosphere is necessary for regulating climate, maintaining a water-friendly surface pressure, protecting against dangerous space weather, and housing the chemical constituents of life. Atmospheres are also crucial for life as we know it. Proxima-B is where? Age, distance, and orbital parameters. The closest exoplanet to Earth is Proxima Centauri b, located 4.2 light-years away from us. Over 20 times closer to Proxima Centauri than Earth is to the Sun. It orbits Proxima Centauri every 11.186 Earth days at a distance of around 0.049 AU. It is unknown if it has an eccentricity as of 2021. Proxima Centauri b probably has no obliquity, albeit. The planet's age is unknown. Alpha Centauri, roughly 5 billion years old, may have grabbed Proxima Centauri, making it unlikely that the planet is the same age as it. It is improbable that Proxima Centauri b has stable moon orbits. Why is it likely that there could evolve life on Proxima b? The closest star system to Earth is Proxima Centauri, which is 4.24 light-years away. Moreover, it is growing closer. In a few tens of thousands of years, it will pass by Earth at a distance of 3.1 light-years. Proxima-B, the first, and thus far only, planet found orbiting it, is located within its star's habitable zone and at a distance that may support liquid water on its surface. Proxima-B is also predicted to have a mass of 1.3 times that of our planet, which suggests that it is almost certainly rocky and just 10% larger in diameter than Earth. It is hoped and speculated that it may have an atmosphere similar to Earth's, the same basic components as our globe, and most excitingly, potentially even surface life. The star Proxima Centauri has a very low mass, at least in comparison to the Sun. It emits only 0.17% of the total light the Sun releases and 0.005% of the visible light due to its extremely low mass of only 12% of the Sun's mass. Proxima Centauri is a red dwarf star which accounts for 3 out of every 4 stars in the universe, unlike our Sun. Red dwarf stars are long-lived, low-mass, cool in temperature, red in color, and radiate most of their energy in the infrared. Like other red dwarfs, Proxima Centauri has a convective interior and extremely powerful magnetic fields, which cause it to release frequent, huge flares, which are also characteristic of red dwarf stars. It possesses solar cycles similar to our Sun, although they last only around 442 days instead of 11 years. It also likely erupted considerably more ferociously in its early years than now, nearly 5 billion years after it was formed. What might be in opposition to life on Proxima-B? Proxima-B orbits Proxima Centauri in just 11.2 days as opposed to the Earth's 365 days around the Sun, since it is far closer to its parent star. With an average orbital distance of only 7.5 million kilometers, which is only 5% of the Earth-Sun distance, it must already be tidally locked to its star, with one side scorching, one side froze, and an intermediary ring that is likely the most temperate region. Additionally, it implies that these flares frequently strike the Sun facing side very closely. While these flares will not completely remove an atmosphere, they will unquestionably remove any UV protective ozone layer on timescales, much faster than a planet could replenish it. Because of this, many assert that Proxima-B is inhospitable to life like that found on Earth. O'Malley James modeled the amount of UV flux that the 4 closest possibly habitable exoplanets, Proxima-B, TRAPPIST-1e, ROST-128b, and LHS-1140b, might be exposed to on their surfaces and compared it to what we experience on Earth. She did this in collaboration with co-worker Lisa Katlenegger. They examined a variety of various atmospheric compositions in the simulations because thicker atmospheres can better protect the surface from UV radiation than thinner, eroded, or anoxic atmospheres do. In the end, the atmosphere of Earth and our proximity to our yellow dwarf sun prevail when comparing habitability to hellfire. It was not always the case, however. The authors write in their research, even though these planets in the HZs of active star systems get higher UV fluxes than the modern Earth, their UV surface flux is lower than that of the early Earth 3.9 billion years ago. Therefore, even for the planet orbiting the most active star in our sample, Proxima-B, the resulting surface UV flux is still around an order of magnitude lower than on the early Earth. This is true even if planets around active M stars have degraded atmospheres or do not contain ozone, anoxic. Life on this planet might be a breeze, depending on the atmosphere and surface water conditions. Winds provide a reliable means of transporting energy as they blow from the light, hot side to the cold, dark side. It seems alarming that there is no shielding against ionizing radiation. But then you learn that Proxima-B emits very little UV light because of its low temperature. Only when these flare-ups occur, which happens about once every 2 to 3 months, is enough UV radiation emitted to destroy the life it is exposed to. Moreover, it's true, even simple, UV-resistant surface life, such as lichens or mosses, would have difficulties. However, even a modest layer of defense would ensure the safety of life. The top 200 meters of an ocean would work fantastically in place of the ozone layer, which is unacceptable. Today's video has come to an end. Give the channel a thumbs up and subscribe if you enjoyed the video. Remember to click the bell symbol to receive notifications when new videos are posted. I will see you in the next video. Until then, bye.